Force is push or pull. Now, how can we understand this definition of force by placing an apple on the table? Let's start our conversation with a simple question. How many forces acting on this apple? Some people will think that there are no forces acting on this because this apple is not moving. It's at rest. It's at constant velocity. So some people would think there are no forces acting on it. That would be wrong. There are actually two forces acting on it. One is gravitational force pulling it down, that the pulling force. Another one is the normal force, comes from table, pushing it up. So here you see the push and fall in the demo. The demo is an object is sitting on the table, which is apple, and gravity is pulling it down and table is pushing it up. Both forces are equal in magnitude and opposite in direction. We can even show these force vectors by this pencil. So this is a gravitational force pulling it down, and this is a normal force comes from the table pushing it up. So this is a pulling force, the green force. This is a pulling force, the green force. This is a pushing force, the yellow force. This is why the object is at rest. When the net force is zero, then object is always at constant velocity. Now, let's understand Newton's second law. What if I remove? Can I remove this force? No, I cannot. Nobody would be able to remove this force. Gravity always pulling the object down. But can I remove this force? Yes. How? By removing the table. If apple collide with the concrete floor, what would happen? There would be action force coming from the gravity, and there is a reaction force coming from, of course, the concrete floor. And let's see what happened, action and reaction. Object is hitting the concrete floor, that's action force. The reaction force is coming from the concrete floor, which is opposite in direction. So this is action force, this is reaction force, which is Newton's third law.